In this video, I'm going to explain how to do problem number 14 from section 4.3 in your calculus book. What you see here on your screen is the graph of y prime. You can find y prime. Knowing how to graph this, though, you would use your graphing calculator. And from y prime we can answer all the questions that are being asked. When is f increasing or y increasing? When is y decreasing? And so forth. And so just wanted to point out a couple key features on this particular graph. Using your graphing calculator, you should be able to find the zero of this function, the zeros of this function, the zeros of y prime. And the first zero is at x equals negative 0.53. The next zero is at 0.65. And the last zero is 2.88. That's not very clear. 2.88. Okay. And so once we have the zeros, we can conduct our f prime test the way we normally do. We have our negative 0.53, we have our 0.65, and we have our 2.88. Okay, and we can clearly see from the graph that f prime, or y prime, I keep saying f prime, y prime is positive to the left of negative 0.3, negative in between those two critical points, positive and then negative. And so we can see that f is, I'll just call it f, f is increasing to the left of the first critical point, decreasing in between, then increasing, and then decreasing. Okay, and then what we can see is then we have a max here at this critical point, we have a min, and then we have a max. Because f prime changes from positive to negative, therefore we have a max, negative to positive, therefore we have a min, and positive to negative, therefore we have another max. Now also, though, from this graph of y prime, we can see that we have horizontal tangent lines right here when x is equal to 0. So in other words, y double prime at 0 is equal to 0. And then way up here, I had to actually add this to the graph, way up here we can see that y double prime, meaning the derivative of this graph, at 2 is equal to 0. Okay, well, we need to figure out where we have inflection points, where y has inflection points. And y has inflection points when y double prime changes from positive to negative or negative to positive. And so inflection points occur when the concavity of the function changes. And we get concavity by doing the f double prime test. And let me just make sure I label this. This is the y prime test. And then over in the first quadrant of our graph, we'll do the y double prime test. Well, the y double prime test, I'm going to have to write over some of this stuff. 0 and 2 are the two y double prime critical points. And we can see clearly that the slopes to the left of 0, the slopes of y prime are all negative. So therefore, y double prime is negative to the left of 0. You can see that the slopes are all positive in between 0 and 2. So therefore, y double prime is positive there. And when I'm saying slopes, I mean the slopes of the y prime graph. And the slopes of y prime are the y double prime values. Okay? And so y double prime positive in between 0 and 2. And then again, we can see that all the slopes of y prime are negative to the right of 2. So therefore, y double prime is negative to the right of 2. And so y double prime being negative indicates that y is concave down from negative infinity to 0. Y double prime being positive means that y is concave up in between 0 and 2. And then y double prime negative means that y is concave down on 2 to infinity. And then that means that the inflection points, let's see what color I can use here. Inflection points would be right here, because y is defined at 0 and 2, and y double prime changes sign at 0 and 2. So we have at x equals 0 and at x equals 2. So those are the two inflection points. So we have concave up, concave down, increasing, decreasing, maxes and mins, and that is how you do it.